All right, last video for lesson 2-2 practice problems. And the concept we're looking at is reference angles. So reference angles are always going to be between 0 and 90 or 0 and pi over 2 as a reference. So if we just look at number 16 to start with, the angle I've already drawn in, so I've already drawn in the angles in standard position. And what I want to look at and focus on, though, is this idea that is the reference angle. It's always, another way of putting it is, what is the angle that gets us back to horizontal as quick as possible? So no matter where you're at, you're trying to get back to the horizontal as quick as you can. So for example, right here, this is our fastest route back. So how far away are we? Well, that's 180 to the horizontal. We went past that by 23 degrees. And that's as simple as that. See? If we look at the next one, we're 2 pi over 3. Well, the fastest route to horizontal is this little section right here. And if we know that this is 2 pi over 3, well, then that leaves us a reference angle of 1 pi over 3. And I know that I went from 16 to 20, but it was in my screen, so I thought we'd just roll with it. So next one up, we have 309 degrees in 17. Well, 309, the fastest way back to the horizontal is right here. We just close that gap. 309, well, we're shooting for 360 to get back here, right? So the difference between those, again, our reference angle is 51 degrees. We keep looking at more problems. We're just going to use the screen problems. I know they're not lining up again, but 21, 7 pi over 4. So again, I've already given you that standard position angle. We are 1 pi over 4 short of a full 360 revolution. So again, that shortest distance we see is going to be just 1 more pi over 4 units back to the horizontal. Next to negative 145, again, you notice the direction of my blue arrow. I am backwards to the negative 145. So in this case, our shortest distance is right here. We need to figure out, well, if we went a full negative 180, we'd be back at horizontal. We went negative 145. So the difference there being 35 degrees. And that's your relative reference angle. 22, same thing, we're going negative. So negative 4 pi over 4 gets us to horizontal. 1 more additional pi over 4 gets us to the negative 5 pi over 4. And again, that shortest distance was pi over 4. To note right now, since we've had a couple of negative angles here, I do want to note that your reference angle is never negative. It's always just a positive, like an absolute value angle for the distance back to the horizontal line. So even though the angles are negative 145, negative 5 pi over 4, or like in this case, up in 21, we're kind of in that negative quadrant. But no matter what, your reference angle will always be positive. It'll always be between 0 and 90 or 0 and pi over 2. So our last two, negative 245, there it is, negative 180, or if you want to look at it as going 3/4 of the way around, that's negative 270 if we would have kept going. So 19's reference angle is right here. It's kind of a big one, but to get back down to the 180, or in this case negative 180, let's see, that's 20 plus 45, so reference angle here is 65 degrees, because we know 180 plus 20 gets us to 200, plus 45 more is negative 245. And our last one, 23. We're looking at 9 pi over 2 as the standard form, and if we draw that out, let's see, 1 pi over 2, let's see if I can do this again. So 1 pi over 2, 2 pi over 2 is just pi. So there's 2, 3, 4, 5, 6, 7, 8 pi over 2, and there's 9 pi over 2. You could also look at it as that's really 4.5, right? 4.5 is kind of like 4.5 pi over 2's. So that's really 2 1/4 times around the circle. So 1, 2 1/4 times around. So nonetheless, we are at the maximum value for a reference angle. In fact, pi over 2 is that reference angle. We are at exactly 90 degrees. So no matter how you look at it, the shortest way back down to the horizontal is either 90 degrees or pi over 2 to the right, or 90 degrees pi over 2 to the left. It doesn't really matter, but that is your reference angle for that. That concludes our lesson 2-2.